Unit 6, Part 2 of 6.1, we're going to look at a special exponential function. And of course, what makes it special is the base number that we use. The function is f of x equals e to the x, but e is not a variable, it's a constant. So like pi, e is a specific number. If you look on your calculator, you see e in two different places, and in one it's always as an exponential, e to the power of something, because we use it so much. So e is an irrational number like pi, which means you can't write it in a fraction form, and even in decimal form you can't actually write the whole thing because it goes on forever and it has no pattern. So you can't put those dots on top to say it forms a pattern. It doesn't. Okay. E plays a very important role in exponential growth. In other words, when you put your money in the bank and it grows exponentially, it grows very fast. It gets more, quite a lot. Population growth is also usually exponential. You have the population grows quite fast. Right, you also use it in continuous compounding. In business. So the exponential growth examples I just mentioned are not necessarily e to the power of something, but continuous compounding in business, I'm sure you all know about that. The direction you're studying, you should know exactly what that means. So then we don't use the 1 plus I to the n, we use the e. Right, so e is called the natural base when you write it in the e to the x form. And the whole function is called the natural exponential function. Right, why the name is important, you'll see when we do logs how that works. Right, when we want to look at the graph of e, what do we look at? What did we say the base must be? Either between 0 and 1 or bigger than 1, but never equal to 1. Well, we've just said that e is 2.718, etc. So e is definitely bigger than 1. So what does that mean? It's an increasing graph. So we would just draw a very general graph of it. Remember that e to the 0, like anything to the 0, is 1. So, please draw straight lines. It's very hard for me to just do it freehand, but please draw straight lines. When x is 0, e to the 0 is still 1. When x is negative, it will be smaller than 1. When x is positive, it will be greater than 1. So when we draw y equals e to the x, we just draw a rough one like this. But it's still an increasing function. And it still has all the other properties of functions where the base number is bigger than 1. Maybe the one property we'll still mention is the horizontal asymptote, because I want you to get that word into your heads. It is still the x-axis, so it is still not just 0, y equal to 0. Right, so e is an increasing function. If something grows exponentially, and it is the natural exponential function, it looks like our increasing exponential functions. We wouldn't try to draw this one exactly. Well, for one thing, e is an irrational number, but we have to know the basic shape of this graph.